Hey, Bogdanovsky here with another video, transformations of quadratic functions. So let's go. In this video, we'll be discussing possible transformation when working with quadratic functions. So there will be translations left or right, up or down, and change of the shape, direction of the openings, which is also called as reflection in the x-axis. So most of the time, you will be seeing a vertex form of a quadratic function. And we'll get through that, how to convert from any other form. Sometimes you will get the standard form, and also you can do that identification of transformations, and from factored form, that is possible as well. But most of the time, you will see, because that's sort of the easiest way of identifying transformation, by having a vertex form right in front of you. So the first example that you see right here is about changing the shape of parabola. So the parent function is defined when the coefficient a, which is not equal to 0, is 1. So you saw this from the introduction, that the parabola shape is in that standard form, opens up, and there is a relationship between x squared and y that forms this sort of the basic shape of the graph. We'll call the parent function, and we will be comparing every other possible shape with that y is equal to x squared. So on this screen, you see y is equal to x squared as a parent shape, and then you have negative 3x squared. So that causes the graph to be reflected. So the change of direction of the opening because of the negative number, and 3 causes the value of the coordinate y to be tripled times -1. So that's why you have negative numbers. But the graph, in comparison with the original, must be slimmer or narrower. So this is the vertical stretch. 5x squared. In comparison to x squared, it is slim, narrower looking parabola because we multiply the output times 5. So you can sort of see the rapid growth of y values in comparison with y is equal to x squared. So the graph branches are far closer together. And when you have a fraction, then you have the opposite effect. You impede the growth. So you multiply by a fraction the output, so you decrease by that factor. So that is called a vertical compression. You're showing the wider graph, and because of the negative, that is why the direction is downwards. So this is the mapping rule that in general sort of converts the original into the new graph when you're identifying coordinates of points. When you have, let's say, identification, let's say 1 and 4, and now you transform under this y is equal x squared times 2, so that 4 will change into 8 for the same value of x. Now, the horizontal translation, the effect of that coefficient h. So let's observe what happens. For example, y is equal to x minus 3. So x minus 3 to the power of 2. When you replace x with 3, then y will be equal to 0. So the vertex from 0, 0, it is translated into 3, 0. By adding 3, the graph is shifted 3 units to the right. So this is the mapping rule when the formula shows y is equal to x minus the number to the power of 2. So when you see x minus h to the power of 2, then that causes the graph to being shifted to the right. If this is opposite, for example, you have right here, y is equal 4 times, so 4 times would cause the graph to change its shape, but x plus 1 in the bracket causes the graph to move by 1 unit to the left. So that is how the horizontal change is read. You take the direction by reading the opposite. So x minus 3, 3 units to the right. X plus 3 would mean 3 units to the left. Now let's talk about the vertical translation, where the shift occurs by adding after the calculation is done, because you do always remember the BEDMAS, right? First you crunch the number with the exponents, right? Whatever is in the brackets times whatever the value of a is, and then you add. So then you would increase the value of y, or if k was negative, then you would decrease, so the graph would go directly down. So this is vertical translation. By moving the graph up when you simply add the number, or moving down when you subtract. So for example, x squared is on the graph, 4 times x squared plus 3. So 4, coefficient 4, causes the graph to be slimmer, to be faster growing, because 4 times x squared, and then you add 3, so hence the coefficient of the coordinates of the vertex went up 3 units up, regardless of what happened to the shape, right? So after, when you crunch the numbers, you transform the shape from being the parent function, the regular, if you will, into a narrower, then you add the coefficient 3. In case you have negative coefficient a and a fraction, you do the math and then you multiply the x squared by that fraction. So you decrease in value, right? So you're causing lower growth, so the graph widens. So this is the compression effect, but because it is minus 2, then you have to drop that graph further by 2 units down. So vertical translation is about straightforward reading. If you add number to the formula, then you move the graph up. If you subtract, you just drop it down. So hopefully that makes sense. Now we do go over some examples where we have complex transformation. So we have the effect of a, the effect of coefficient h and k put together. So parent function y is equal to x squared. Now we have 4 times, so that's going to be expressing the vertical stretch by factor of 4, right? X minus 1 in bracket causes the graph to be shifted 1 unit to the right, plus 3 units up. So from this point, 0, 0, the new coordinates are 1 and 3. This is how the vertex is transformed. Similarly to this other example, when you have negative 3 and minus 2, how is that visible from the vertex form? Because we have in brackets x plus 3. So we move 3 units to the left. Minus 2 at the end causes the graph to be dropped 2 units down. And of course, that negative 1/3 changes the direction of the opening and changes the rate of growth for the function. So it is much slower. So that's why it causes the graph to be wider than the parent function. So hopefully that makes sense. So now you have this beautiful sort of summary where you see the vertex form of quadratic function and the cause of transformation, or maybe the effect of transformation done by coefficient a, coefficient h, and k. So remember how each coefficient creates the change with the graph. This is just the shape and direction of the opening. This is the movement left or right. And this is the movement up or down. So once you have it down pat, you're becoming a master of transformation of quadratic function. And now you have this beautiful chart where each transformation is nicely described. So when you go through that, you will have the ability to identify what happens with the parent function under each particular transformation. And this chart right here will make much more sense after you've gone through some exercises, and then you will see that oftentimes the graph will be given in that standard form. And by using the quadratic formula, you can identify the coordinates of the vertex without changing into the vertex form, because you just average the x1 and x2, add it together, divide by 2, and hence you have negative b over 2a. How do you find y coordinates? You put that value back into the equation and boom, you have it. So this is what it says, f at that x. How much is y? In other words, when x is equal to negative b over 2a. When you have this factored form, right, the coefficient a is factored out, then I have x-intercept at p and q. So how do you find the location of the vertex? Because the graph is always symmetrical, then you add those coordinates, divide by 2, like you did in quadratic formula. Add, divide by 2, boom, you have the location of the x coordinates of the vertex. How do you find the y coordinates? You use that value of x, you put back into the formula for x, you calculate, and there you go, you have the y coordinates. So that is also possible when vertex form is not presented, or if you don't want to change standard form into a vertex form, or you don't want to change that factored form into a vertex form, you can still find a vertex, right? Axis of symmetry is correlated with the location of the x coordinates of the vertex. That is the same value. So x is equal to k represents, sometimes mathematically speaking, a number. X is 3, so that is just location on the x-axis, but also this represents a vertical line equation. X is equal to 3, that means y is any real number, but x is consistently 3. Therefore, you have a vertical line. So axis of symmetry is represented by an equation, not just a number. All right, y-intercept is always found when x is equal to 0. So that's simply saying when you plug in 0, regardless of the formula that you have, you calculate how much is y, so it's always there. And coefficient a is defining the concavity or direction of the opening. In other words, the same thing, that when it's positive, opens up, concaves up. When it's negative, concaves down, opens down. Domain is the independent x variable that you can use to identify the input value, and that has no restrictions. Any number, big, small, negative, positive, square root, you name it, would work. But the range is represented by the location of the vertex and direction of the opening. If it opens up, then you have a minimum point, and any number above from that y coordinate of the vertex upwards represents the range. And when the parabola opens down from that maximum point of the y coordinate, you represent the interval showing that from this number downwards. And x-intercept is only visible from the that factored form. You cannot tell x-intercept from standard form or from the vertex form because it is not possible. And sometimes there's only one x-intercept, sometimes 0, and sometimes 2. So this is the only form that allows you to identify 2 because the form shows x minus root 1 times x minus root 2. So obviously that makes sense. So thanks for watching. Hopefully you have now a better idea and better understanding of what transformation of quadratic function is all about. Do practice questions. Don't walk away until you complete. Identify the x of symmetry, x-intercept, y-intercept, direction of the opening, transformation that actually is involved in each question. Thanks for watching. We'll see you again. Bye for now.